Next type of question we'll look at is what's called triangle questions. And you recognise them in the exam because they look very much like this, and I've got a second example for you in a moment. There's a few ways of doing these, but I think the triangle method is the best method, and it's once you're used to it and you've done it a few times, these can be pretty easy marks in the exam. So let's have a look. So we've got sine theta equals 12 on 13. Now I'm going to look no further than that. I don't care what the rest of the question is, because I've got enough information now to set up a triangle. So I'm going to put here theta, whoops, sorry, theta here. And remember, sine theta is opposite, which is 12, over hypotenuse, which is 13. So I've set up that situation there. So 12 over 13. So what I need to do now is find out this other side. I'll just call it x here. Now you might already know that the three numbers here in this triangle are what's called a Pythagorean triad. They're a set combination of numbers that fit for right angled triangles. That is 5, 12, 13. But I'm going to presume that you're under the pressure of the exam and you don't know that, and you're going to need to find out x using Pythagoras' theorem. So x squared, okay, will be 13 squared minus 12 squared. X squared equals 169 minus 144. X squared equals 25. Therefore, x equals 5. So my missing side there, I'm now going to rub out x, and I'm going to put 5. There it is. Alright, what I'm going to do now is, once I've done that, I'm just going to erase this working here, because I'm going to use this space now to actually solve our question. So I'll just get rid of this stuff here. I might get a bigger duster here, make it a bit easier. Okay, so now we've got our triangle. We have to find cosine theta and tan theta. Now, we're told here in the background information, and I haven't got any further yet than just finding out that third side, that the angle that we've got is in between pi on 2 and pi. That is its second quadrant. Okay, remember our quadrants? Okay, it's in that second quadrant there. Okay, and what we know about the second quadrant, according to our cast diagram, of course, is that we know that we've got C, A, oops, C, A, S, and T, that in that second quadrant, only sine is positive. So both cosine and tan will be negative. So this is what our thinking is from here on. We've got our triangle. We know that cosine, sorry, start again. We know that cosine is adjacent. Just going to rub that out again there and just sneak the 5 in a bit there. Okay, we know that cosine is adjacent, which is 5 over hypotenuse 13. So cosine theta is 5 on 13. But because our angle, our theta, is in second quadrant, cosine is negative in second quadrant, it's got to be negative 5 on 13. So the answer is negative 5 on 13. Tan theta equals the opposite over the adjacent, so that's 12 on 5. Okay, opposite over adjacent. And because tan is negative in second quadrant, our answer there is negative as well. So our two answers, cosine theta negative 5 on 13, tan theta negative 12 on 5. Okay, so the process there again, you've got two sides of your triangle from there. Okay, opposite and hypotenuse, find the third side. Nothing else matters at the moment. Then look at what quadrant you're in, and then once you find cos and tan, make sure your sine, S-I-G-N, is the correct one for the quadrant that you're in. Let's try another question. Let's forward a few slides. Here it is. This is in the 2013 exam. Given that this time theta is in between pi and 2 pi, so it could be third or fourth quadrant, and tan theta equals negative 3 on 4, find cosine theta. Alright, so it's got that triangle question format again, but it's a bit tricky. I'll just draw the triangle and then we'll talk further. So there's our triangle. Now, when we set up our triangle, the fact, and I'll really emphasise this, that we've got a negative there doesn't matter. We don't call one side negative 3, okay? the negative there is irrelevant in setting up our triangle. All we know is that we've got an angle here, and tan is negative 3 on 4. Ignore the negative. 3 over 4. Opposite over hypotenuse. Opposite over adjacent. And then we can put in our hypotenuse, which is 5. Now, you may already know that that is a set triangle, 3, 4, and 5. If not, you can work that out using Pythagoras' theorem, but I've filled that out. So now we're finding cosine theta. Cosine theta equals what? Well, cosine will be adjacent over hypotenuse, so 4 on 5. Now, what quadrant are we in? Well, we're told that our angle could potentially be between pi and 2 pi, but we're also told that our value for tan is negative 3 on 4. Now, because tan is negative, that means our angle cannot be in third quadrant. Why? Because tan is positive in third quadrant. So this missing angle that we've got is not, even though we're given that it could be between pi and 2 pi, this angle is in the fourth quadrant. Okay, so theta is in fourth quadrant. Why? Because we've got a negative value for tan over here. Okay, and it can't be second quadrant because we're told that this angle is only going to be found between pi and 2 pi. So, given that we're in fourth quadrant, and given that cosine is positive in fourth quadrant, our answer is indeed positive. There is our answer, 4 on 5. Hope that helps with the triangle questions.